properties of reflected figures. So we just did one of these. It was properties of translated figures. So this is just the same idea. We're just going to reflect the figure. So we have 4 translations, and I keep going over this. So we've been doing transformations now for a couple weeks, so I'm hoping it's starting to sink in. We have translate, rotate, reflect, and dilate. So translate just means move something right, left, up, or down. Rotate means that we're going to turn it, which that's what rotate means, right? Reflect means if I have my hands here like this, and we're pretending like there's a line right here in between, and I'm going to reflect it right over that line. So now they're backwards from each other, but they're the same figure. And we can think of that as like a mirror image for a reflection. And then dilate, which was my 4th one, was to make change the size, not the shape, the size. So if I dilate something, then I make it larger or I make it smaller. All right, so we're going to talk about reflection. So in this case, what we're going to do is we're going to reflect a figure across whichever axis they're asking us to. And I'll show you the reflection tools on the next page. And then decide if the statements are true or false. Remember, translate, reflect, and rotate do not change the figure. So any of these statements that talk about a change, side lengths being different, angles being different, parallel sides not being parallel anymore, anything like that is false for these 3 things. For translate, reflect, and rotate. They have to be the same once you're done doing one of these 3 things. Dilate is the only thing that will change the side lengths. It doesn't actually change angles. It only changes the side lengths. And it won't change the parallel either because the figure is still the same. So dilate's the only one that can affect the side lengths, but that's all it does. So these 3, though, we won't change anything. All we're doing is moving the figure. Okay? So if we scroll down here, we can see we have a reflection line, and I'll show you that on the next page for the tool. And it will automatically reflect it for us once we put the line where it's supposed to be. And then we just read the statement. So it says the final side lengths are the same as the original side lengths. Okay, same. That's good. True. The final angles are the same as the original angles. Awesome. The same. That's what we want to hear. If 2 sides are parallel in the original figure, then those sides are parallel in the final figure. Perfect. Sounds like we haven't changed anything. The original figure and the final figure may not be congruent. So the main thing on this one is read the whole statement. It doesn't say they may be congruent. It says they may not be congruent. Well, that's not true. That means we changed something. So we click false. All right, so let's go ahead and try this one out. So we have reflect the figure across the x-axis. Then decide if the statements about the reflected figure is true or false. So to reflect it across the x-axis, we want this line here. So the x-axis here. So you see we have 2 reflection tools. If I click on them, it automatically puts a line. Well, I don't want to reflect across the y, so let's click on the other one. There we go. That line is going the right way. And because it said across the x-axis, that's the line. That's where I want to put the red line. It's right there on the x-axis. If I click on it, it flips the figure for me. I don't have to do anything else. So that's reflected across the x-axis. So now the final angles are the same as the original. Perfect. We haven't changed anything. The final side lengths are longer than the original side lengths. Oop, longer. That makes it sound like I've changed something, and I haven't changed anything. I just moved it. The original figure and the final figure may not be congruent. We just talked about this. Just be careful about the wording. The 2 figures are congruent. All I did was I took one and I flipped it down. I didn't change anything else about it. I just flipped it. So this is a false. If 2 sides are parallel in the original figure, then those sides may not be parallel in the final figure. Again, may not. That makes it sound like I changed something. So false. Check. All right. We're good to go. 2 more of these. Reflect the figure across the y-axis. And then decide if these statements are true or false. So y-axis is going up and down. So I'm going to pick on my tool that has the line going up and down here. So it shows you the line if you look at the tool here. So I want to go on the y-axis, and it flips it over there for me. One of the things to remember about reflection is if this one is 4 units away, so if I go from the blue line here, I'm going 4 units. It's going to do the same thing on the other side, so it's going to go 4 units to the left. So that's all it's doing, is it's making sure that it's the same units away, but backwards. So It completely reverses it because when I flip my hands, they're not like this. That would be a translation. So it flips it over. It's backwards. Okay. So the final angle measures are larger than the original. That's never true. So that's false. Even if we do a dilation, the angles are the same measure as they were in the original. There is a kind of cool thing we can do with that if I had a projector and stuff like that. But I'm sure there's videos we can find about how angle measures don't change when you dilate a figure. It's kind of cool. If two sides are parallel in the original figure, then those sides are parallel in the final figure. Perfect. That sounds like we didn't change anything. The final side lengths are the same as the original. Perfect. Didn't change anything. And the original figure and the final figure are congruent. Again, perfect. Sounds like we didn't change anything. And we didn't. Okay. So next, we are going to reflect this across the x-axis and then decide if the statements are true or false. X-axis goes from right to left. So we want to choose the one that has the line going from right to left here. And then I'm going to click right on x-axis because that's what it told me to do. So now we have these two figures, and they're both 2 units from the blue line. So this is 2 units down. This one's 2 units up. Okay? So that's just the idea of reflection there. So if two sides are parallel in the final or in the original figure, then those sides are parallel in the final figure. Perfect. Completely true. The final angle measures are the same as the original. True. The final side lengths are longer than the original. Well, that wouldn't be true because that would mean that we changed something. That's only true if we dilate the figure. And dilation, we'll get into that later. We have done a couple of dilation, but this one is only reflection. Reflection, the side length should be exactly the same. The original figure and the final figure are congruent. So we've already said true to that on a couple other screens. So remember, the two figures are exactly the same. I just took one and flipped it over, but I didn't change the figure. I just moved it in kind of a funny flip way, but all I did was move it. All right, we're done.